So yeah, my name is Ben Lafreniere, and I'm going to be talking about some research in software learning and skill development. And so just a little bit of background on me before I kind of start. I work for Autodesk, a large software maker in Toronto. And Autodesk is a world leader in 2D and 3D design, engineering, and entertainment software. Our software can be used to do all kinds of things, and it's safe to say, you know, if you've driven in a car recently or admired some crazy skyscraper or some impressive feat of engineering, or watched a movie or whatever, our software was probably somewhere in the pipeline for that. And in particular, I work for Autodesk Research in the user interface group, which is headed up by George Fitzmaurice. And so we're a group of HCI researchers, and we look at a whole bunch of different topics. Here's kind of a selection of them that you can see there. But one of the longest running themes that we've had in our group is learning. How to enable people to learn complex software. And maybe that shouldn't come as a surprise because we make really complex software. So in our lab, we publish papers at top conferences. We've had over 70 HCI research papers over the past 10 years, mostly at CHI and WIST. And we work with top interns. We have a really active internship program, and many of the people that you see here, after doing internships, have gone on into faculty positions and on from there. But kind of stepping back, I want to talk about the particular area that I look at. I'm really interested in feature-rich software, programs like Photoshop or AutoCAD that have hundreds or thousands of features. These programs give people enormous expressive power to do all the sorts of things that I was talking about. They're really tools that amplify our human capabilities. But all of this capability comes at a cost. They also require training and learning before people can use them up to their full potential. And in the early days of HCI research, circa 80s and 90s, this was a real topic of interest. And it's kind of not hard to see why. This was when the personal computer industry was just ramping up, and in workplaces all over, these machines were coming in, and people were faced with the task of learning these complex tools. And so this book on the left by John Carroll was this sort of summary of kind of a decade of his research, identifying the challenges that people faced and the potential solutions that could address these for people learning. But kind of stepping back, by the time I started my PhD in 2009, this was a topic that was seeing a lot less attention. And I kind of blame this guy. This is, of course, Steve Jobs introducing the iPhone. And I don't have a lot of data to back this up, but Apple really at this time upped the game for interface designers. Suddenly everybody wanted to make interfaces that were simple, beautiful, usable. You shouldn't have to like figure out how to use it. It should just be obvious. You just kind of come to the thing and you know how to use it. And that's an amazing goal. But for a number of areas, that's just not possible or really even desirable. So there's the complex software that I was talking about earlier. And then there's also examples like keyboard shortcuts or other expert interaction techniques where you can really improve your performance, but it really requires some time up front to build up the knowledge and capability to use them. So just as an outline, I'm going to talk about a number of research projects that I've done and my interns have done around this general theme. So starting with my PhD work, I was really interested in this idea of just-in-time learning, of how you could, and particularly how you could enable non-expert or occasional users to perform these tasks that were new to them in these complex applications. So if you're this guy here, you're sitting in front of the GIMP image editor, an open source image editor, and you want to recreate the effect on the top. Well, how would you do it? Well, the actual way that you do it is you duplicate the layer, and then you desaturate the duplicated layer. Then you add a layer mask. And then by painting on the layer mask, you kind of reveal through the colored layer underneath. But what I want to kind of point out is going back to this guy, the interface of this software is not providing much help with reaching this goal. The commands themselves are split between several top-level menus, and they're kind of organized by categories, and they don't indicate which commands are related to the user's goal or how they might be used. And so this kind of raises this interesting question. So could you organize an interface around high-level tasks that are of interest to the user rather than these taxonomies of commands and tools? What might this look like, and is this a feasible approach? And so I'll show a design that I developed and a study that showed that, yeah, we can do this, and that this sort of task-centric interface allows people to perform tasks faster and reduces their cognitive load. So this was the interface prototype that we developed, and sort of a search engine within the software. And then it brings up these sort of tutorials, but then more than being just a tutorial, it actually walks you through the process of doing the task. And you can click the buttons in the we call them workflows, to perform the task. And so to evaluate this, I conducted a study of people using our workflow system on the left, and the standard GIMP plus, you could search things on the web on the right. And what we found was that participants were faster, and then kind of more importantly, they were still faster 2 weeks later coming back to it. Because one argument you could make is, okay, yeah, you're going to be slower the first time when you're figuring it out in the full interface, but then you're going to know it, and then you'll be fine going forward. But actually, people muddle through, they half learn it, they get to the goal, and they really having something that walks you through it can be benefit time and again. And then also participants reported lower cognitive load on this. So I experimented with this idea for the GIMP image editor, but you could really imagine a kind of global search engine, something like a Google, but for tasks. And I think that this is really kind of a cool idea. I'm convinced that somebody's going to run with this and try and create it eventually. But it kind of raises this question. If you had this sort of a search engine, where would these thousands, tens of thousands of interfaces come from that people would then use? And that kind of led to the next chunk of work that I did in this space on community-driven software learning systems. So as some background, one of the main ways that people learn complex software is through web-based tutorials, many of them which are created by the community. And these are fantastic, but they're separate from the application. They're not integrated into the application in the way that I showed for the workflow system. And also, they're static. They don't react based on how people use them. So maybe everybody gets stuck at step 3 in here, but the author of the tutorial never finds out that everybody's stuck at step 3. And if somebody else comes along and they figure out a way to do something really tricky that's in one of the steps, maybe they could leave a comment on the tutorial, but that would just wind up in a big list of comments at the end. It's not really indexable. And it doesn't really improve the tutorial for the next person that comes along. So this led to a project on what we called community-enhanced tutorials. And the idea was, if you could link this software application with some tutorial content, the tutorial could kind of grow additional demonstrations over time by looking at what everybody was doing. So the interface design is a bit messy, but we had an application embedded, and then the tutorial instructions, which you could kind of page through. And then the system would watch what everybody was doing on the individual steps, and then feed that back in additional video demonstrations for subsequent users. One of the kind of cool things is we could do tricks like, depending on which what type of an image you loaded into the software. It would kind of reorder the demonstrations to try and show the most relevant one, the closest match, and some cool stuff like that. And so we ran a study on this, and we found that participants do actually make use of additional demonstrations when they're available. And that's kind of important. Maybe people would just ignore them, but we found that people actually do use them if they're available. And they also appear to have the potential to make tutorials more robust in terms of quality and task similarity. So the idea is you could put up a tutorial that was for a very specific task and maybe wasn't the best quality, but then through this kind of accretion over time of additional demonstrations, it could improve the quality. And this kind of led to another project where we thought, well, if you've got the capability to watch what people are doing and record video and log data of it, over time you're going to get this massive library of videos and log data of people working, doing real-world tasks. So that's a cool resource. What could we do with that? And at the same time, there's some previous research done also by researchers at Autodesk that said that short 10 to 15 second video clips embedded in tooltips are this really, really valuable help method for getting people to understand how to use tools. So these are some tool clips for AutoCAD. But the challenge here is that authoring tool clips for an application's entire feature set, that's just a huge undertaking. AutoCAD has more than 1,000 features, and only 35 of them had tool clips as of the time that I did this research. And maybe it's gone a bit up since then. But the point is that it would be a real effort to author of all of those. And if it was just 1,000, you could say, okay, hire a team, get them on it, make that happen. But tools like AutoCAD are used in different industries, and maybe the right clip is going to vary industry to industry. So now you've got 10 industries times 1,000 features. Now you've got 10,000. It could go even higher. So because there are now tools for capturing people's workflows, Autodesk has this product called Screencast, which you can use to record. You could record your screen, and it also captures log data, and then it puts it into this big cloud library of these. Because this now exists, there's this giant corpus of videos out there. So this raises the question, could you take short segments from this big corpus that exists and then repurpose them as tool demonstrations? And so in this work, we looked at kind of two questions that underlie this. One is, do good demonstrations actually exist, just kind of naturally? Do they just naturally occur? And if so, is it feasible to automatically extract them? And I won't go through the whole process that we followed, but we got people to record themselves just doing tasks. We developed some heuristics for chopping up video onto clips around command invocations. And then we did some studies of the quality of that. And so one of the things we did was we took all the clips that we had identified, and we had some experts rate this sampling of clips for the question, how good would this clip be for demonstrating how the specific tool works to a novice user? And the first thing that you can see is that it's skewed very negative. There's just a lot of crap. More than 50% are 4 or lower. But you do have this 3.6% of clips that got a very high rating. So that kind of indicates, yeah, in all of here, there are some good demonstrations. So I'll just show some examples. This is a very poorly rated clip. This is a clone stamp tool. You see the person, I'll play that again. They kind of pick up some region. There's this weird panning action. You have no idea what's going on. There's a terrible clip. But here's another example of the same thing. The person selects the tool. They select a source region. And then they use it to paint out a feature in the thing there. So this does clearly demonstrate this is how the clone stamp tool works. Here's another kind of bad example. This person selects the gradient tool, and then looks like they're being really careful. And then it just blows away everything. Why were they doing that? Who knows? Who knows? But then you have this other example here, where they select the gradient tool. They actually select a pattern, which is kind of nice. It shows you this is the mechanism that you use to change the type of gradient that you want to apply, and then they apply it. So that's sort of a good example. So overall from this project, we found good demonstrations do naturally occur. And also in the paper, we talk about how this question of whether or not you could automatically detect the good clips from the bad clips. And we found that the features of good clips, it's kind of a mix of features that are algorithmically detectable, things like the extent of change to the document of that, and some that are more subjective, like aesthetics or the document that you're working on. But overall, our conclusion was that machine learning shows promise as kind of a first pass approach, and then you could consider a system where people kind of rank clips or people up or down vote them as a second pass to get to the really good ones. So now I kind of want to switch gears a little and talk about some work I've done a bit more recently on introducing 3D design software to kids. And so just as some background, right now, kids have unprecedented access to 3D design software. You've got, it's a bit hard to see, but on the left you've got a kid at a computer with Tinkercad, which is an Autodesk product there. And Tinkercad is just at Tinkercad.com. Anybody who has access to the web can go to Tinkercad.com, and they have a pretty full-featured 3D solid modeling tool available to them. Also, 3D printers and other digital fabrication tools are showing up in libraries and makerspaces and schools and that. But just making these tools available, it's probably not enough. There was kind of this phenomena in the early days of personal computers where schools were like, computers, like kids need to learn computers, so they get the computer and they put it in the corner and it just sits in the corner because there's this training that's required to use it. And so there's sort of this similar thing going on with 3D design now. So to kind of kick off work in this area, an intern of mine, Nathaniel Hudson, did this study to figure out what are the potential barriers to kids learning individually how to use this sort of software. Is it realistic to expect that kids could go to Tinkercad.com and just kind of follow some tutorials and figure it out? In particular, we wanted to evaluate common online learning resources, different types of tutorials that are online, and also whether or not things like web search and community forums could help them to get unstuck if they did get into a situation where they were stuck with things. And my intern will be presenting this work at CHI in May. And so kind of the overall findings from this was that kids really struggle with the standard resources to support independent learning. We tested video tutorials that were integrated in the application, and ones that were text and image based. And with all of them, they ran into some real trouble moving forward. Moreover, things like web search also didn't help very well. They would oftentimes find pages that were kind of unrelated to the task at hand, or just kind of give up because they had trouble making sense of the stuff that they found. In the same study, we did some interviews with people who run group workshops, and we found that group workshops are actually a much more effective environment for kids to learn 3D modeling. They also come with some challenges for instructors, which I'll talk about in a second. But they are an effective medium. But it's kind of too bad because, if that sparks some interest, then they go home, they go to Tinkercad.com, they've got the software there, but then they run into this trouble and they don't have any way of kind of helping them get forward. So motivated by this, there are two projects that me and my interns have been working on over this past year to try and address these challenges in kind of interesting ways. So some of this is kind of late-breaking work. It's not published yet, but it's cool, so I want to talk about it. So the first is, we call it the Minecraft to Cad project. And the motivation here was, while 3D modeling is quite difficult to learn, many kids and adults spend just hours and hours building in Minecraft, and they do it just for the enjoyment of the experience itself. And when you think about it, what they're doing here is a kind of 3D modeling. It's just a block by block version rather than using these kind of big solids. So we're asking this question: can we leverage the activities and motivations and knowledge of people who play Minecraft to teach them 3D modeling concepts? And also, as a kind of fringe benefit, there's just a ton of people with this skill out there. So if we could create this kind of bridge from Minecraft into 3D modeling, and even a small percentage of people were to cross it, that would be great. And so here's a video of the system that we developed, and where's the timeline here? Wanted to skip ahead, but so there's some sort of motivation stuff in here, but eventually it'll get to the actual system. Yeah, so, yeah, okay, so here's the system that we developed. It starts users out in a kind of standard Minecraft style interface. You can create things block by block. But then it's watching what you do and what you build and your behavior. And then over time, when it thinks it's appropriate, it unlocks these new capabilities. So the first one is this tool for stamping trees. But while it's a tool for stamping trees, it also kicks you out to a third-person perspective that's closer to what you'd see in a 3D editor. And once you've used that for a bit, it unlocks a feature of a 3D navigation widget. That's a view cubed widget, which is across all Autodesk software is used for 3D navigation. And then if you're creating kind of geometric shapes, it unlocks a shape drawer for pulling out solid shapes, which then turn back into things there. And that's the same as in Tinkercad. You can kind of see where this is going. Over time, it's building in more and more features to bring you closer to the interaction model of Tinkercad. Resizing of shapes unlocked next. And then finally, it unlocks this work plane tool, which is a tool for an advanced tool in Tinkercad for putting shapes on the faces of other shapes. And so essentially at this point, once somebody's unlocked all of this, they're essentially doing 3D solid modeling in the style of Tinkercad, just doing it in a Minecraft environment. I won't go into the evaluation details, but the overall idea here was to start in Minecraft and sort of gradually alter the interaction model, the tools, the conventions, and even the appearance of the interface to resemble Tinkercad. So rather than having this experience where to learn a new application, you are dumped into an environment where none of your existing skills work and you have to learn the basics again, you take a comfortable environment and then you add these kind of motivated learning scenarios to build on these new things. And we did a study of this where we had a group of users use just a Minecraft-like game where you could just create with blocks, and then have another group use our system that we had developed over 20 minutes, and then we had them do transfer tasks just in Tinkercad, try and create these tasks in Tinkercad. And so what we found was, first, participants do use the unlockable features when they're available. We didn't force them to use the features that were unlocked, but the majority of participants did try them out. And second, they didn't say, oh, you're trying to slip learning into my fun game here. They actually liked using the features, and they rated them positive on some post tests. And then participants were able to successfully apply the skills that they learned in the game back in when they were using the full Tinkercad interface. So overall, this appears to be an effective approach for teaching Minecraft players Tinkercad skills. And I think that it would be interesting to look at how this same general approach could be used to create kind of a pathway from playing Minecraft to Tinkercad, and then Tinkercad to more advanced tools, so that kind of over somebody's whole lifetime, they kind of have a smoother path to the advanced tools that they could use to have a rewarding career or things like that. So the other project that that we're working on in this space, this one was done by an intern of mine, Vladimir Dzyabac, who is at the University of Manitoba, was about real-time orchestration of 3D modeling workshops, group workshops. So here's a picture. It's not of a Tinkercad workshop, it's one that I pulled off online, but it kind of does express what group workshops look like. So as I said, these are really an effective way of teaching these skills, but as you can see, they're super messy. You have an instructor, and if the instructor's at the front of the classroom, you just have a ton of kids at computers. You can't really see what they're working on. If you demonstrate something, and then with the presumption that they're all going to follow along, you have no real idea if half of them are lost or if they did things right. And there might be students who are having trouble and are vocal about it, but you might have other students who are running into trouble and they're not speaking up or they're not saying anything, and so they're just kind of like falling behind. And so we were kind of interested if we could provide a tool that would help facilitators by giving them a greater awareness and maybe automating some of the ways that they typically assist students. So our overall approach was to instrument the Tinkercad application to send data back to our system, and then display to the instructor the state of each student's editor and provide these tools to send these kind of learning interventions. So the interface consists of a whole bunch of tiles like this, one per student. It shows the state of the student's editor and a timeline below that shows the commands that they're and activities that they're doing. And then it has a capability of sending some targeted kind of messages to the students. But I think that the part that's really interesting is we also had some features to augment the instructor's awareness. And hopefully this is playing. Yeah, so one of I'll just talk over this while it's kind of getting to the part that I want to show. But one of the challenges that kids oftentimes face when they're doing 3D modeling is that they won't change the camera viewpoint, so they'll do everything from one perspective, and then things will look like they're here, common challenge, not changing the 3D view. Things will look like they're lined up, but then when you change the camera angle, actually things are all kind of separated apart. So, and another challenge that's pretty common is kids just kind of, stop doing anything or just kind of become distracted or that. So here's the interface to the system, and one of the features that we implemented was if an instructor does something, the system is then watching to see which students do that, and then it highlights them in green, so you can get a real-time sense of who's following along or not. Did 80% of the people follow or not? Also, if somebody hasn't used 3D navigation in a while, it pops up this thing, and by tapping it, you can send a quick reminder to the student to say, hey, don't forget to change the 3D viewpoint. But kind of a critical point there was, this is kind of optional. So we're using this kind of intelligence to try and suggest these learning interventions, but we're not doing it for the instructor. We just want to give the instructor more sort of a recommendation. So then if you're an instructor and you see, oh, this guy hasn't changed his 3D viewpoint recently, but I know that he's a good student. He's totally aware of this. He's been doing this for a while. I won't send that to him. So by keeping the instructor in the loop, you kind of reduce the instance where an automated system kind of recommends something and it becomes a nuisance. So we ran a case study with this where we had a facilitator come in and run a workshop with 14 kids, and we got some really promising feedback. They appreciated the features that I talked about a second ago, and they kind of expressed that the system could kind of extend their reach. So they said, oftentimes there'll be certain students that need some additional attention, and so I want to stay around them, but then I lose awareness of what everybody else is doing in the classroom. So this allowed them to kind of maintain that awareness while also helping out students. But a key challenge for this work is minimizing the cost to the instructor's attention. These workshops are so busy already, and then you're adding an extra thing that they have to attend to. And so in our prototype, I don't think we did that as good as we could. And so that's kind of an area that's an open question for improvement. So most of the work I've talked about so far today is focused on learning of higher level tasks and skills. But there's another form of skill development that I've done some research in as well, and that's on expert interaction techniques. So basically, how can we get people from using novice methods like menus and toolbars to more efficient expert techniques like keyboard shortcuts or gestures in some systems? And I think that this is actually a really interesting area of research because most people, most of the time, just don't use expert interaction techniques, even after they've used software for many, many years. And if you think about it, in aggregate, that's just a huge drag on people's potential productivity. And so specifically, I've done some work on this idea of novice to expert transitions in rehearsal-based interfaces, in particular fast tap menus, which I'll describe in a second. First, I'll step back and tell you what rehearsal-based interfaces are. So in the 1990s, Kurtenbach came up with a really interesting idea, the principle of rehearsal, that states that the guided actions of a novice user issuing a command should be a physical rehearsal of the way an expert would issue that command. So the kind of classic example is marking menus. So a novice user places a pen tip down and pauses, and after a short delay, the radial menu is displayed, and then they can make a selection. So if they wanted to select the fruit and vegetables option, they would wait, and then they'd swipe up to open the groceries submenu. A submenu would open, and they'd swipe to the right to select the fruit and vegetables option. But an experienced user who already knows the layout of the menu can just go up and right without even waiting for the menus to appear. So the expert technique is just a sped up version of the novice technique. And so fast tap menus use the same principle on sort of tablet-based systems. So for a novice selection, you touch the menu, wait for it to open, and then you make a selection. And for an expert, you can tap the menu and the location together without waiting for the menu to appear. So again, the physical actions of making this expert selection are a sped up version of the corresponding novice selection. So the promise of these interfaces is that this rehearsal principle will just naturally lead users to transition from doing novice selection, getting faster and faster and faster, until eventually now they're using expert selection, just based on the incidental learning that occurs while they're doing it. But there wasn't a lot of evidence for this. And so we did some work to test this in greater detail. And specifically, this was some work I was involved with. Mainly, this was done by Carl Goodwin and Andy Coburn. But they looked at two applications, one a fast-paced game and two a drawing application. So here's the game. You have to select the color that matches the circle that's following, and then you have to slice it before it gets to the end of the screen. There's 3 stages to the game. Slow wave, which you're seeing now, a medium version, a medium wave, and then a very fast wave, which is shown in a moment. These were designed so that each drawing would take about 60 selections, so 180 selections per week. So over the 10 weeks of the study, participants did 30 drawings and made on the order of 1,800 selections. So for some perspective, that's 6 times the number of selections made in the fast-paced game sim. So what did we find? Well, what we found was that in the game, participants very quickly over the 20 minutes went up to 80% use of the expert technique. They very quickly transitioned. Whereas in the drawing application, after 10 weeks and 6 times as many selections, they still were using the novice. And so, first of all, there's some obvious differences between the 2 case studies, and maybe they're playing somewhat of a role. You have a different number of items in the 2 menus. Where we played with different versions of the game application, and in some of the drawing application as well. So first we did one where we did slow, medium, fast, and then another slow stage. So, would people, when it goes slow again, would they maintain it, or would, now that the performance requirements dropped, would they go back to novice? So what we found is that they actually keep using the expert technique, or they even increase their discipline. But okay, that's kind of interesting. But maybe they expected that another fast stage was coming. So we did another study where we said, let's just have a static block at the end. So we'd stop people after the slow, medium, fast, and we'd stop them and say, okay, there's one more block. In this one, the circles are going to appear. They're not going to move. You could, it's the last block. There's nothing more after this. You can kind of complete it at your leisure, basically, right? And we still find that they kind of continue to use the fast edit. So this is really interesting. So it seems like the performance that they've built up, or their transition to the expert technique, seems to stick even after the performance requirement is then reduced. So this raises a really interesting question. Could you use the game to get people using the expert technique and then put them in the drawing application, and then they keep using the expert technique? So we decided we test that. So we developed a drawing application and a game that have the equivalent set of items. We recruited 10 new participants that hadn't participated in any of the previous studies that had Android devices. We installed both the game and the drawing application on their devices. And in the initial session, we had them do the game for 20 minutes, and we sent them home, and we sent over the week, we sent them drawings to. So the first, you notice that the cat drawing kind of is on all of the days. That's because we thought, well, maybe for a drawing that's novel, they won't use a certain technique, but then once they've done it and it becomes more rote, they might. But we had a whole set of drawings. And the final one on day 7 was the cat task, but then we also created a task that we draw whatever. So here's the data for the game session. Just to say that everybody in that initial 20-minute game, they picked up the expert selection method and became very good at it, actually. Everybody transitioned to using the expert technique. So then what do you think happened for the drawing tasks? Do you think that they all reverted to the novice technique? Do you think they all stuck with expert? In any theories? Okay, yeah. So here's what we actually found was that the results were strangely bifurcated. We had 5 people that stuck with the expert technique, and 4 people that went completely back to the novice technique, and only 1 person that was kind of in the middle. And this person was kind of an odd case because their Android device had like a really broken screen, or this really kind of weird thing. And they clearly thought a lot more, it seemed like they had thought more than some of the other participants about these sort of 2 things. So this is really kind of interesting. We had designed the study with all these different tasks, thinking, well, maybe the nature of the different tasks would have an effect. But actually, we see people kind of go one road or another. So what does this all mean? Well, the first kind of nice takeaway is that a high performance requirement can push people to adopt an expert technique that, at least for some people, persists even once the performance requirement is removed. So in terms of design of training, that's actually great news, because you use this kind of a fast-paced game, and then kind of, for some people at least, have something continue on. The second interesting thing is that there's this tendency to sort of select the technique and stick with it across sessions. So you could have imagined that each different new task might, people would almost choose based on the task or a situational factor like that, but it actually seems like they kind of stick with it one over time. And then I think that kind of the bigger takeaway is that there's real potential for more investigation into what influences whether skills are adopted and whether training will persist after somebody leaves a training context and goes into a real world setting. So just kind of going back to the start of my talk, software and technology, they enable us to do these incredible things. And they have the potential to help us solve all kinds of big problems that we face in the world. But I think that we're really limiting ourselves if we're always looking for a walk-up-and-use solution that doesn't require any training. So kind of given that, there's this real need for HCI researchers and practitioners to grapple with the challenges of enabling people to learn and use complex technologies and develop their skills and abilities over time. There's tons of great research to be done in this area, and I'm really interested to continue to look at it. So, thank you. I'd be happy to.
So, when we look at, say, like the performance requirement really pushing people into starting to perform expert actions, what do you think the takeaway or maybe the issues that you have to be aware of with these feature-rich software suites that you discussed earlier would be? Like, would you add gamification elements into things like this, or would there be limits just because there's so many more expert actions?
Yeah, I guess there's kind of two issues there that I think are really interesting. So the first is that we actually started designing an Inkscape slicer. So it's sort of like trying to apply this technique, the same sort of technique to feature software. And you can imagine that that could be pretty simple. Like you would use the kind of idea of bubbles falling, but then you have to perform keyboard shortcuts to kind of slice them. So that's the one thing that I think is interesting. But the other is that you really have to take into account the sort of change in context. So in this case, the action of selecting the item was the same in both, but if you had something like a flashcard system, right? Well, it might be fine if the flashcard system to say, what is the keyboard shortcut for copy, and you can click on something that's Control-C or Control-X, right? But it's better if you actually perform it. So all of this sort of stuff we've got in that last study is a journal paper. We kind of try and tease apart all of this as a kind of general metric of distance between the training context and the usage context. And so I think that that's kind of a useful way of thinking about it. And so even with these feature-rich applications, you can still imagine training contexts that are closer to the usage context or ones that are a bit far away. And actually, a third point that I'd add is one advantage that we had was we were training people on all of the commands in this drawing application. So people who had gone through the game, they learned 100% of the commands. And when I presented this work to some other people, they said, yeah, but when you only know 20% of the commands, or you only know the 5% of commands that you need to get your work done, maybe then you're always making this decision in your mind. You can't go 100% or zero. And so maybe that's an additional barrier. And I think that this would be really interesting to test because for something like Photoshop, you can't train somebody on 100% of the keyboard shortcuts. You're going to have to limit it. So they're going to be doing some stuff with the mouse, and they're going to be doing some stuff with the keyboard shortcut. And there's this question, does that monkey with the silver button?
I have a completely different kind of question. I was interested to see the study you were running in the pictures of the kids there. And that immediately made me wonder what your ethics process is for working with groups of kids, because that's something we've had arduous difficulties with in the past, and I wondered how it worked in the industry setting you guys are.
Definitely, no. So the first project was under a MyTax grant, and working with our intern was from the University of Waterloo. So we went through the full ethics process at the University of Waterloo, and followed, the best practices around that for running that study. Our second study, the workshop one, that study we were running it ourselves, and so we didn't have an Office of Research Ethics to go to, but we followed all the practices from the previous study to basically try and ensure as much as possible that we're following everything correctly. Yeah, it's something that we know that we don't have an obligation to go through a process like that, but all of us in the lab have come from academic backgrounds, and so we're like, we want to go over the top on being careful with that. But it's definitely
Where did the kids come from?
they're mostly recruited as children of Autodesk employees for this second study, the workshop study, and then kind of snowball sampling some of their friends also involved. For the first study, it was kind of a mix, some Autodesk kids of Autodesk employees, and some, one of the researchers in our lab is involved in these kids' local sports team, and so we kind of put out the call there, and so some of them got some of that.
Thanks.
With your just-in-time learning stuff, do you see like machine learning really taking on a large role in that, and like predicting actions that people will be using, or understanding what kind of actions the users are already doing, per se?
So there's, I think that, I think that machine learning will face some challenges in automatically generating instructions for people to follow. I think that's going to be tough. What I think a potentially valuable use for machine learning in that kind of context is maybe looking at the searches or looking at the queries that people perform, or looking how people use the software to identify maybe a candidate set of tasks that there aren't workflows to support. So we had this idea, we called it parking spaces, right? But the idea was, use intelligent tools to try and find areas where there aren't enough tutorials, where there's kind of missing areas of knowledge, and then maybe have a human work on it. And more generally, because the idea in that task-centric interfaces work was to just get the user to the result. Because we're looking at occasional users who don't care so much about learning the system, they just want to get to the end result. You could imagine certain steps where like a machine learning algorithm could do the step for them, or provide an intelligent tool, like Adobe has a lot of these content-aware fill tools and things like that. They're using intelligence to try and automate what was once a manual process.
So my question about expert. So you mentioned about you want to build a system that help the user become an expert. Do you see that? Do you think that expert means that person knows 80%? You mentioned like 100%, but at the same time you mentioned about casual. This person wants to change the field, and then the expert for that person is like, I just need to be able to do this task, and I'm very good at it.
Yeah, so I didn't talk about it, but previous to that task-centric work, we did some log analysis work where we looked at just tons of logs from people using an instrumented version of the GIMP software. And what we found was that most users just kind of learn a small corner of the system that they need for their particular tasks. And sort of digging into the literature on this, what I found that this is actually a pretty robust finding over all kinds of complex domains, is that nobody learns the whole software. Everybody learns just the corners of it that they need. And on the one hand, that's good because you're not faced with teaching people everything. On the other hand, people say, well, you got to make the stuff that everybody does easy, right? But what they're missing there is that the stuff that person says everybody does is the stuff that I do, right? And it's different, right? And so you can't just simplify the interface so that it's easy for the most common tasks, because the most common tasks vary so much person to person.